When we talk about cutting-edge AI, a few big names always dominate the conversation, right? You've got your OpenAI, your Google, Anthropic. But today, we're looking at a new contender, a really powerful open source model that's stepping right into the ring to challenge those champions. This is the story of DeepSeek V3.
I mean, think about it. It is a massive undertaking. The big labs have almost bottomless resources, just oceans of data, and literally the world's best researchers. So, how on earth does a new player even start to compete at that level? Well, for starters, you make a very, very bold claim. And that's exactly what the team behind DeepSeek V3 did. Right there in their technical paper, they come out and say it. Their model can go toe-to-toe with the best, most expensive closed-source models out there. That is a huge statement. So let's see if they've got the goods to back it up.
Okay, so let's properly meet our contender. We're about to dive deep into DeepSeek V3, a model that, let me tell you, is already making some serious waves.
So, at its heart, DeepSeek V3 is really about two key things. First, it is open source. That means its code, its architecture, it's all out there for people to see, to learn from, and to build on. That's a huge deal. And second, it's been engineered from the ground up, not just to be smart, but to be incredibly efficient.
In the world of AI, you can't just say you're good, you have to prove it. And the way you do that is by putting your model through this brutal gauntlet of standardized tests, we call them benchmarks, and you publish those scores for the whole world to scrutinize. And for DeepSeek V3, let's just say the results are very, very interesting. All right, let's get into the main event. This chart right here says it all. You can see DeepSeek V3 in blue, and it's being compared to some of the heaviest hitters out there, including the brand new Claude 3.5 Sonnet. Now, look across these different tests, from general knowledge to coding and math. It's not just playing in the same league. In some cases, it's winning or coming in as a very, very close second. I want you to focus on this one number for a second, 90.2. That is DeepSeek V3's score on a really tough math benchmark. This is absolutely state-of-the-art stuff. It shows this incredible skill in mathematical reasoning, which for a long time has been a major weak spot for AI. And this isn't just about math. Look at this comparison on the MLLU Pro test, which covers dozens of different subjects. DeepSeek V3 actually edges out the just-released Claude 3.5 Sonnet. Now, yeah, GPT-4o is still out in front, but this result proves this model can absolutely hang with the very latest proprietary releases. So these scores are fantastic, but how? How did they pull this off? Well, the secret isn't just about throwing more computing power at the problem. It's about a really clever design choice. And that design is called Mixture of Experts, or MoE for short. The idea is actually pretty simple, but it's incredibly powerful. Instead of having one single gigantic brain that has to know everything about everything, an MoE model has a whole team of smaller, specialized networks, the experts. Then a little component called a router acts like a project manager, sending each question to the expert that's best suited to handle it. This diagram kind of shows you how it works. A request comes in, and that router in the middle takes a look and decides which of these smaller expert networks to wake up and use. It's just like having a team of human specialists, a mathematician, a writer, a coder, and you only call on the one you actually need for the job at hand. And here's the key difference right here. A standard model has to fire up its entire massive brain for every single calculation, which is just incredibly expensive and inefficient. But the Mo model, it's way more efficient because it only uses the fraction of its brain that's actually needed. It is literally working smarter, not harder. But that mixture of experts design is just the starting point. The DeepSeek team also came up with several other key innovations to push the performance and efficiency even further. This is the real secret sauce. Now, we're not going to get totally lost in the jargon here, but these terms, they represent some serious engineering breakthroughs. They're all about making the training process faster, more stable, and more efficient, from how you manage the experts to how the model actually learns. Let's just speak at one of these tricks, the dual pipe algorithm. Think about training an AI like a factory assembly line. Well, this algorithm is a genius way of overlapping the different stages of the process, so there's almost zero downtime. It's a way to keep those expensive computer chips, the GPUs, running at full throttle, which dramatically speeds up the whole training process. And here's another really clever innovation. It's how they handle numbers.
See, to make calculations faster, they use a less precise number format, but that can sometimes cause errors. So they came up with this really sophisticated strategy to use these fast, low-precision numbers for most of the heavy lifting, while keeping the really critical calculations in high precision to maintain accuracy. It's the best of both worlds. You get the speed and the quality.
Okay, so we've got a super smart, super efficient open source model. That's technically impressive for sure. But what does it actually mean for the rest of us? What's the big picture for the future of AI?
Well, the first thing you have to understand is the absolutely staggering cost of all this. Training a model at this scale requires a mind-boggling amount of computer power, and that translates directly into millions and millions of dollars.
I mean, just to get a sense of that cost, look at this breakdown from their report. The team calculated the computer time, the GPU hours, and the rental costs. The first stage alone, the pre-training, took over 2.6 million GPU hours, and that by itself cost over $5 million. And here it is, the final number from the paper. Over $5.5 million. That's just for the compute costs to train this model. A number like that really drives home why all those efficiency tricks we talked about are so absolutely critical. Every single percentage point of improvement saves a fortune.
So let's pull all this together. What does this all mean? Well, first, it means a model that can compete with the absolute best is now open source for anyone to use and build on. Second, these new innovations prove there are smarter, more efficient ways to build these things, potentially lowering that enormous cost barrier. And finally, this is what healthy competition looks like. It pushes the entire field to get better, faster. And all of this leaves us with a really fascinating question. For years, the cutting edge of AI has been locked away inside a few closed-door labs. But if open-source models like DeepSeek V3 can now truly go head-to-head with them, well, we might just be entering a new, more open, and maybe even more exciting era of AI development.